Test, test. Test, test. We're good now.
Okay. Moderate amount of light. Yeah. And we don't switch them to whatever's out there. As far as I know, we can do that. Yeah, welcome in, folks.
Constructed in the picture. This is a architect that did this drawing here of the site, but I thought it was pretty cool because there were probably maybe 1,000 people living here, and they had to grow a lot of corn to feed everybody. And so off there in the distance where those open areas are, even close by, they were growing corn, beans, and squash. The three sisters, you know about those? Corn, beans, and squash. Practically a perfect diet. And yeah, so we're going to go up on the south end of, do I have a pointer?
I don't believe so. I can maybe, nope.
No.
I don't believe so.
Usually have a pointer. Anyway, I've got a lot of back pain, so I can't stand up. But you see what's over the top of the ridge over there? That's the San Francisco Peaks. Of course, we're from a higher elevation looking down, so but you can't see the peaks from this site, okay? But as you follow that kind of line that goes up a little bit to the right, goes up to the top of the end of Anderson Mesa right there, and that's where we're going to go. Chavez Pass is just down below here on the right. Next. So here's the sign that sits there at Chavez Pass. Nuva in this name here is means snow, and the translation for that in Hopi is snow belt, because when it snows in the wintertime, it'll be snow on top of the mesa, and it's long and flat, and it looks like a belt. So that's what the Hopi name is. And like I said, 1,000 people probably lived here, etc. Next. That's the same sign, and we're looking up on the ridge where the two 500-room pueblos are located. And just right in the middle there at the top of the ridge, you can see the back wall of the northern pueblo on the ridge. Next. This is my friend Bob Tularovic, also was a docent at the Museum of Northern Arizona. And he's standing in one of most of those rocks there are volcanic. Can you imagine using all those various shaped rocks to build 3 stories high? That's why it fell down so much. It's not in as good a shape as a lot of places that used, for example, sandstone that you can shape and build, you know, several stories high, and it's still standing today. But not at this site. This had to require a lot of maintenance to maintain it. So we're going to go up to the top of the end of the mesa there, and there we are. And this is the part of the Petroglyph site here. In the foreground where my red hat is, I sit on that sometimes to take the photographs that you're going to see, and I call that the shadow casting rock, and I'll show you in a minute. Now let's look at the Patkey clan symbol over there. See it on that rock back there? I noticed that right away, and I knew that the Patkey clan, next slide, the Patkey clan symbol is a turtle. So I knew this was a Patkey clan site. Now that clan is still in charge of keeping a calendar at First Mesa at Hopi. This is an ancestral Hopi site, okay, from 800 years ago. Next. Here I am on the shadow throwing rock, and on the north side of the shadow rock that you see right there below me, that is shaped. That shape, this is basalt. Basalt breaks in sharp corners, edges. Not like that. That's shaped to the arc of the rising sun or moon. And why is that? So that see the shadow line over there to the right? That's on a spiral there on the right side of the petroglyph panel. And as the sun rises, that shadow stays in the same place because it's coming off of this rock, which is shaped to the arc of the rising sun. This isn't the only place they did that. I'll show you some of those later. So this is probably in February because that shadow line right there is about mid-February going through that spiral. But all the time that the shadow line is going through that spiral marks the beginning of at least at First Mesa today, marks the beginning of the Puwamu ceremony, which we call the bean dance, because they grow some bean sprouts in the kiva where it's warm in the winter, and then they harvest them and take them around to the village, and we call it the bean dance. That's not what they call it. They call it the Puwamu ceremony, which in Hopi means the water moon. But that water moon occurs over the whole month of February, starting at the top on the right side of that spiral, and it leaves, it's starting to get into March on the lower end of the spiral. But like I said, that shadow line stays in the same place as the sun rises. Next. So here we see another phenomenon. When I first saw this, I couldn't figure out where is that dagger coming from. And I was trying to feel, well, I finally had to stand down there and look and see where it was coming from in a totally different place, not off of this rock at all. That's a dagger. So I think the next slide shows, no, it shows the same shadow line right there with the moon up above. We're going to get into the moon later. Okay, next. Oh, this is the shadow line exiting the spiral, and that's the whole panel. On the right is a 7 counterclockwise turn spiral. If you're starting in the middle, it goes counterclockwise. Has tick marks on the outside all the way around. Then you see the hook cross, and to the left of that is what I call circle dot. And next to the circle dot on the left is what I called sun in its house. Those are the main elements that I'm going to look at as we try to figure out what's going on here. Next. So now the shadow line has moved to equinox. This picture was taken exactly on equinox, and it's tangent to the hook cross. 4 days before that, the shadow line was going through that cupule right above the hook cross. So Hopis always announce the ceremonies 4 days in advance. Everything happens in fours in Hopi, by the way. I should tell you another incident that shows that. That hook cross, that's tangent, that's the shadow line, doesn't move as the sun rises, stays in the same place. And that's equinox, March 21st. And the sun is moving most rapidly on the horizon at this time, at equinox. The sun is moving on the horizon about a whole solar diameter every day. It's moving. And then it slows down as it gets close to the equinoxes, winter or summer, and then stops for a week. We'll get to that. Next. Okay. Now we're looking at the eastern horizon where the sun rises. And the sun in this picture is rising over the highest point on the far eastern horizon. And let's see what's happening on the panel. The shadow line is going right through what I call the sun in its house. Let me just, so there's a circle, a half circle right here, a cupule right there, and then this thing that I call the house over the top of all this. So I called it sun in its house. And so that's where the shadow line was. Well, I showed this to my Hopi friend, Lee Kewanwai Sioma. He's retired now, but he was the chairman of the Cultural Preservation Office for the Hopi tribe. And he was a friend of mine, and when I happened to have this picture with me, and the sunrise over the highest point on the eastern horizon. I said, what do you think's going on here? He says, well, there's probably a shrine on top of that mountain. And then his next words out of his mouth is, when are we going there? And I said, well, if you know me, I've already tried. And you guys own this cattle ranch here, which owns that whole mountain as well, that mountain that the sun was rising on. And they said, well, if you had a hunting license, we could let you up there, because there's several gates you have to go through. But I don't think you have a hunting license, do you? I said, no. Well, then you need to talk to the chairman of the Hopi Cultural Preservation Office. You mean Lee K1YComa? Yeah, that guy. Okay, I said, he's a friend of mine. So, next picture. So there he is on the left. That's Lee. Norman Honani, which was a assistant ranch manager on the cattle ranch. And that's a young man, I don't remember his name now, from Lee's office that worked with him. And so he said, yeah, when are we going there? And I told him, well, I've already tried. I couldn't get there. He says, no problem. You come with me, you're okay. So we arranged to go on, I'll never forget this date. And we hiked up to the second highest place on the mountain called Mesita Knoll. And up there on top were three fire rings on top of the mountain. And I said, oh, look, somebody's been doing smoke signals. Smoke signals? We don't do that. I said, why? It gives our position away. So what do? He says, we yell. You want to hear a Hopi yell? I said, sure. Man, he let out a blood-curdling yell that you could hear for miles, I'm sure. Anyway, so I was still up at the top taking pictures, okay? And these guys walked down to the west from the Mesita Knoll, the second highest place. And pretty soon Lee, hey, Jerry, come on down here. So I walked down here, and these guys were individually, now you might think that's lichen on this rock cairn standing here. It's not. It's pollen. Cornmeal from their pouches that they carry. And each one of them individually sprinkled that shrine with corn pollen and then said a prayer individually. And when I got there, they were still doing it, but I got there, I waited. Then Lee turned around and said, you want to take a picture of us three Hopi musketeers at our ancient shrine? I said, sure. So that's it right there. So anyway, we hiked back down, got in that SUV, and started driving up to the highest point to see if there was a shrine up there. And I told him, I said, well, there used to be a radio tower on that highest point, and it's been torn down. And I'm sure when they put the radio tower up there, they had to use a bulldozer to create a cement pad to put the radio tower. I said, I don't think if there was a shrine up there, I don't think it's there anymore, but let's go check. So we got in, and this road was really rocky. You could go about as fast as you could walk. We finally got to the base of the highest point. I said, well, the road goes on around. I could see it on the topo map. Goes on around to the top, but I said, we can walk up there faster than we could drive. So we got out, and I had noticed as we were going along that there was a lot of clouds and lightning to the north of us. And I was watching the flashes, and then I heard the thunder, and it was getting closer and closer and closer. But we got out and started walking up to the top. And by now, the thunder and the lightning was flash bang, and it started raining. And Lee says, let's get out of here. So we ran back off and jumped in the SUV and hightailed it down the mountain. And the heavens opened up. Just cloudbursts like you can't imagine. And we could hardly see where we were going. And we could see that there was waterfalls literally coming off this mountain when we were down below. And then there was a ditch that came across there, and it looked like a flowing river. And we stopped, and And Lee asked Norman, the ranch manager who had the key to all the gates, do you think we can get through this? And he says, yeah, but you're going to have to gun it and go as fast as you can. And you might slip around a little bit, but just keep your foot on the pedal. So that's what we did, and we got through it, but water was going all over the place. So we finally got out to the pavement, and I said to these guys, I said, I'm very impressed. I said, you guys found your ancient shrine, you blessed it, you said prayers, and the heavens opened up. This was the first monsoon storm of the season, July 9th. And they laughed. Yeah.
What did the shrines look like? Were they stacks of rocks?
Yeah, a rock cairn. This was on the edge of a cliff.
Oh,
Yeah.
that's it behind?
Yeah, that's between the two guys there. And like I said, the yellow stuff there is their corn pollen that they sprinkled on there. Yeah. Next. So now, here's the sun rising over that shrine, the Meseta Knoll, that little bump over there where the sun is rising, and it's on the west face of that. The sun is rising over that shrine. Is there anything happening on the panel? Let's see. Ah, look at that. It's tangent to the circle dot. Now, it's the season when the sun is going back to winter solstice, and the shadow line is moving this way. So it already went through the cupule there in the center of the circle dot. That was 4 days before it went on the edge of the circle. And so maybe this was marking another ceremony that went on at that time. This was in September, by the way. Next. So I drew an accurate, I have this on a big whiteboard like this, so I could kind of, and this is to scale. I scaled it out. That's the elements that I was talking about. It's interesting, you know, you think about this, how did they set this up? How did they do this? Probably took more than one generation to figure this all out. But you notice that there's a straight line through the sun in its house, the circle dot, just below the cupule above the hook cross. Then it goes through those two cupules in those partial spirals. And that's a straight line there. The shadow line is tangent, 90 degrees to that line. Maybe that's part of how they set this thing up. I don't know, I wasn't there, but that's a possibility. The hatched area is where the shadow line is at certain occasions. Yeah. Okay, next. Okay, let's go back to this sun dagger. I'm standing right in front of me on the lower right here is the two rocks that form the dagger on the spiral. And what's interesting is that upper rock, which is separate from the other rock below it, that is shaped to the arc of the rising sun or moon. Haven't got to the moon yet. But this is the sun dagger on May 27th and July 16th. What's significant about that? Well, first of all, notice that the sun dagger is hitting the center of the spiral. Now, Hopis say corn is life, because that's their staple, has been for over 1,000 years. So it's very important to know when it's not too early, not too late to plant corn so they can get it harvested in the fall. When it hits that center, there, May 27th, that's time when they plant corn. It still is at Hopi today. And July 16th, what's that? Well, that's the same number of days after summer solstice as the planting time is in May. And that's the Puamu, no, that's the Niman ceremony, the going home ceremony. when the Katsinam go back to the San Francisco peaks, leave the villages, and then the Katsinam dances are over for the season. So what do you notice? It hits the center of the spiral, right on the nose, and then the upper part of the sun dagger stays in the same place. Notice the bottom one, that's 35 minutes after sunrise, and 10 minutes earlier, 10 minutes earlier, and then 0. So what you notice is at the bottom, that rock that's forming the bottom of the dagger is opening up, getting bigger. But the upper one, because the upper part of that sun dagger is shaped to the arc, the rock is shaped to the arc of the rising sun. So it stays in the same place as the sun rises. Next. Okay, summer solstice, sunrise. This is over West Sunset Mountain. To the right is the beginning of Sunset Pass. Highway 87 comes through Sunset Pass from Winslow, paved road, if you're familiar with that. Yeah, June 20th, 2004. Next. June 20th, 2004, 20 minutes after sunrise. See where the dagger is way over there on the right. It's not interacting with anything. Then it hits the, 30 minutes later, it hits the outer edge of the spiral. And 40 minutes later, it has crossed the spiral. But the position of the upper one is in the same place, and it's how many rings down from the center? 1, 2, 3, 4. It's tangent to the 4th ring. Would I say everything happens in 4s? Okay. That's summer solstice. And that sun dagger will stay there in the same position for a week, because the sun, for all practical purposes, does not move at summer or winter solstice for a week. We have the date, December 21st, winter solstice. Summer solstice, June 21st or 20th, depending on the year. But 3 days before that date and 3 days after that, for naked eye observation, the sun does not move. That's why it's called solstice. Sun stop. It's a Latin term. Sun stop. Solstice for 1 week. Okay, next. Oh, that's just another detail of that. Next. Now, what is interesting that is all this observation occurs in the north side of the maximum and minimum. Maximum sun position would be summer solstice. Winter position would be on the horizon to the south, to the right as you're looking at it, sun rising. And practically all these places that are doing calendar stuff like this, they only pay attention to the north end, the maximum extremes on the north end, not the south end. That's interesting. But I saw this petroglyph here, just below this calendar panel, a perfect circle with a point on the end of it. And I said, I wonder what that's pointing at. I looked across Chavez Pass to Chavez Mesa or mountain. Across there, it's a perfect flat. And that's where the winter solstice is. But that's all that marks it here. There's no interaction with anything else, just an arrow pointing across over there where the winter solstice actually rises. Next. So I'm sitting there on the shadow throwing rock. The sun has already been up for a while, thinking about all this. What's it all mean? What's it connected to? Next. Okay, let's take a look. Okay, the bottom picture here is looking to the west. Highway 87 going south is that road over there on the right. There's a fence over here, and on the left is East Sunset Mountain, and on the right is West Sunset Mountain. And you're looking at Chavez Pass, right where the arrow points, okay? On the right I'm sorry, on the left of that is Chavez Mountain, or Mesa, actually. And on the right of the pass is the southern end of Anderson Mesa. Okay. Now on the upper one, I'm standing at the Petroglyph site, looking east where the sun rises. So it rises over Chavez Mountain, starting at winter solstice, which would be, I think I have another diagram that shows that. Winter solstice would be right about here. Equinox, let's see, that's right about here off the end of that mesa. This is East Sunset Mountain, high point, second highest. West Sunset Mountain, summer solstice would be right about here. Sunset Pass here, back to Winslow that way. Okay, next. Okay, now we're going to talk about the moon. The moon has what is referred to as an 18.6-year lunar cycle. The maximum and the minimum positions of the moon, I said that the sun stops at summer and winter solstice for about a week. But the moon, for keeping track of it on the horizon, stops in the maximum position, or the maximum southern or northern position, for 2 years. It's a long cycle, 18.6, about almost 19 years, the full cycle. So you're looking at the Earth, the North Pole, and the lunar orbit. And the lunar orbit in minor standstill position, I'll show you what that looks like on the horizon. Minor standstill below is 5 degrees, looking on the right side, is 5 degrees below the ecliptic, where the sun path is. Okay, and then it's the opposite on the major standstill, is 5 degrees above the sun. So its orbit is moving like this, okay, around the Earth. Next. Okay, so now I'm showing the northern lunar standstill maximum and minimum positions related to the summer solstice, 60 degrees on the left there. Maximum is 5 degrees further north, about 55 degrees. The minimum is about 65 degrees. And the southern maximum and minimum is illustrated over there. Now, they don't pay any attention to that in all the sites that have calendars like this, just the northern part. Okay, next. Now, I took a picture of the southern maximum lunar standstill on June 11th, 2006, and the summer solstice would have been right about here. That's 5 degrees further to the south. But they don't pay attention to that. Next. So, a very faint moonrise, December 15th, 2005. That's the first time I saw the lunar dagger on the panel. That's the maximum northern lunar standstill where that arrow is out there. That's West Sunset Mountain. Next. Now this is partway in between. This is the full moon rise in December 19 on its way to the maximum lunar standstill position to the left. The maximum will start in 2023. I have pictures of it in 2024, but that doesn't matter. It hasn't moved. The standstill position lasts for 2 years. So this is an interesting picture. This was taken by Scott Thibany. Some of you may know Scott. He's an archaeologist, a writer of magazine articles and books. And that looks like a tree on fire. I promise you it's not on fire. His friend, who's Scott's friend, came out with Scott and I on this expedition here, and his friend is a backcountry survivalist, and he demonstrated his expertise by finding just some kindling and a couple sticks, and he made a little fire at the base of this tree. The tree's not on fire. Just this little pile of twigs and stuff on the ground. That's illuminating the tree that makes it look like it's on fire in the picture. And after we took the picture, we stomped out that fire anyway. So there was no fire there, just a light on the ground. The same time that the moon was rising. Isn't that awesome? Now, I want to point out something else to you. Sometimes, you know, we go out for sunsets. Okay, we like these beautiful sunsets. But have you ever looked at the eastern horizon? What's going on? It's fantastic. So it's somewhat illustrated here. It's not as good as it is sometimes. But you see this blue line right here going across. Guess what that is? That's the Earth shadow after the sunset, projected onto the eastern horizon, setting in the west. But that Earth shadow is projected through the sky, and that's the shadow line of the Earth right there. And above it is the sun still shining through the atmosphere up here. Sometimes it's really pink up here. And then the moon is rising in the shadow line. So look at the eastern horizon when the sun is setting in the west. See what's happening. Looks pretty cool. Next. This is a western sunset. This is Tony Marinella, a fantastic nighttime photographer. I've been up here with people that have smartphones, and they say, oh yeah, we can get these night shots of the lunar dagger, you know, at night. None of them got anything, just blank, black pictures of nothing. Tony takes pictures. I'll show some of his pictures. He takes these pictures at night with the lunar dagger. Now you can see it very clearly with your eyes if you get adjusted to the dark. And you can see that lunar dagger just pops out at you. But they couldn't get it on their smartphones. So I called up Tony because he got the minimum, let's go to the next slide. Okay, that is the northern minimum lunar standstill, December 17th, 2014, at a 67.5 degree azimuth. That's the position of the moon rising at sunrise, that many degrees from true north. Okay. Oh, by the way, I should tell you also, I give credit to the Naval Observatory data section. You can find out the tracking of any major celestial body, like the sun, the moon, certain stars, and it'll give you all the information practically every second of that heavenly body in the heavens. And you can take paper and track it exactly where it is, where to look for it. The guys that use telescopes and know what the angle of degrees are for catching whatever they want to look at, they get their data from the Naval Observatory. And we could not use compasses here. Compasses could not tell us where that, because all those rocks around there are loaded with iron and manganese. And the compass wants to point at the rocks, not what you want to look at. So they were hopeless. But the Naval Observatory was great. You give them your position where you are, your elevation, and then you tell them what date you want, and they give you exactly where that heavenly body is going to be, okay? Like 0 altitude at sunrise or something, where you were at. Or you have to give them the elevation too. So that's the lunar dagger with Tony's camera. No other light. You can even see this petroglyph panel like it's almost in the daylight. And that's at the top of the spiral. The upper edge is at the top of the spiral. That's the northern minimum lunar standstill position. Next. Now this 2023 was the beginning of the maximum lunar standstill. And we're hiking up here to the mesa top to catch pictures on a smartphone, which got nothing. Anyway, we tried. Let's go up. Just before you get to the top, there's this petroglyph image here with 4 people. Remember, everything happens in 4s. 4 people and somebody on the right there. I don't know what they're doing. Looks like they're dancing. Okay. That's interesting. That's the only other petroglyph except for that circle with the point on it pointing to the winter solstice. Next. Next. Okay. So this is the best picture. That's the top of the lunar dagger. Can't you see the lunar dagger there? We had to do that with a flash camera. That's where the top of the lunar dagger was at maximum lunar standstill. We tried it. You got nothing on the camera. So this is a flash picture. Next. Now, in 2005, that was the last lunar standstill before the one we just had. Northern maximum lunar standstill at Chavez Pass, November 18, 2005. And that's the lunar dagger there, that dagger on the left. That's transposed over an image with a flash of the spiral. And this is probably at least an hour after the moon rose. Okay. And I got that picture with black and white film, 800 ASA pushed to 1600, and got the lunar dagger. That's how, the only way you could get it back in the day. Next. Northern maximum lunar standstill, December 15, 2005, about 19 years later. That arrow is pointing down to where the moon rose. And the moon is now, after an hour after sunrise, it's up in the sky there, and it's still in where the sun is shining through the atmosphere. You see that blue line below the moon? Again, that's the Earth. And then the pinker color is the sun still shining through the atmosphere and the Earth shadow. It's not real clear there, but that's what you're seeing. Next. That is the northern maximum lunar standstill position on December 15, 2024, up there with Tony. That moon was rising at 5:30. The summer solstice sunrise would be right about in this position here. This is 5 degrees farther north on the horizon, northern horizon. Next. Now this is with Tony's setup. Maximum lunar dagger, December 15, 2024, 6:30. We did not get the dagger on the panel until an hour after the moon rose. Why? Well, I should have been paying more close attention, but the picture of the moon rising was not taken where the notch is that makes this. It was further away, and you could see the moon rising. Why don't we have the dagger on the panel? Because where the rocks were like this, to make the dagger, that was further north, and there was a juniper tree that was blocking the moonrise. So it took an hour before we got the lunar dagger on the panel. And this was taken exactly at 6:30, an hour when we first saw it, because it had cleared, the moon was high enough, so it cleared that tree an hour later. Next. Now notice that dagger has moved down. Go back one slide. Right there is the top. Next. It's moved down to here. Now that distance, I took that distance times 5, this was 11 minutes separate. He had a time-lapse camera, another camera going time-lapse. That's how we were able to get this picture, these pictures. So we saw that the dagger had actually moved about that much. So I multiplied times 5 that distance to see if what it would have been when the moon originally rose. And it would have been going through the cupule in Sunninet's house. Now, I have no pictures to demonstrate that because I didn't give that juniper tree a haircut, which I had to do the first time I was out there with Brian Bates. I had to give the tree a haircut so we could get the moon rise or sunrise coming through. Yeah, so if anybody wants to go out there and give that juniper tree a haircut and see where that lunar dagger actually is when the moon first rises, that would be awesome. But I'm moving to Oregon. I'm not going to be working on this anymore. So if anybody wants to be adventurous, that's your assignment. Next. Okay, now I'm going to show you a few other places that have calendric function. This is in Picture Canyon, by the way. That's a spiral in Picture Canyon with the sunrise at 0 degrees. That means it's on the horizon, just cleared the horizon. 20 minutes after it rose on April 7th, 2008. Now you see that very distinct shadow line going through the center, almost the center of the spiral. And what's interesting is that shadow line is coming from a rock, next picture, coming from that rock, which by the way is shaped to the arc of the rising sun. So that shadow line stays in the same position as the sun rises. Okay? So you see where the sun is just peeking around there. It's actually over like one of those cinder cones over there, just east of that Picture Canyon. But that line right there allows, as the sun rising will follow that line at that time. Next.
About 5 minutes.
Okay. This is Waukoke Pueblo, early in the morning, summer light. And you see a tower there, it's 3 stories. And I did some work on that too. Next. That's what it looked like in 1954. That's the southwest corner. That's where all the storms come through and eroded that. The other 3 corners of the 3rd floor of the tower are all perfectly plumb up and down. And the Park Service repaired that corner. And but that it wasn't plumb with the first 2 floors like the other 3 corners. They were better masons than repair people today. Next. So this is a window. This is pretty faint, but that's the beam of light coming through the north window in the tower at summer solstice. Next. So this is a diagram of the tower. This is the summer solstice sun coming through that window in the 3rd floor. That's where it hits the wall. 5 degrees below that is, I projected, that's where the maximum northern lunar standstill would shine into the southwest corner. Does it do that? Next. So here we are, Waukoke Towers on the right, southwest corner, a few minutes after moonrise. I was out at Chavez Pass, if you might remember, in 2005 in November. And I had a crew here taking these pictures. This is a placard I put up, a white placard to catch the moonbeam. Now that first one, you can see the moon is not illuminating the top of the tower, but it is on the second one, which was 18 minutes later. See how that has moved? But this first picture, it's a few minutes after. Next. So we went out there in December, and the moonbeam, not very bright because the moon is practically doesn't have any light coming through because of the clouds. But it's right in the position where it would have been if they had the plumb line in the correct position. Next, that's the moon. It's practically not much lunar light power there. Next, this is at Chaco Canyon, 3-slab site. And what you see at the 3-slab site is in the next slide. So we have sun and moon, equinox, summer solstice, winter solstice. That's when the sun is up high in the early afternoon. We have the lunar midpoint, the minimum extreme lunar, minimum lunar standstill on a line that goes through this, and the maximum extreme at moonrise over here. So they were marking that moon and sun as well. Next. This is a Chimney Rock site in southwest Colorado. That's a great house on the ridge there on the bottom. The moon rises at maximum northern lunar standstill between those two. Next. That's about where, next. So there's a moonrise between the two rocks. Next. So after all this heavy work, time to stop and smell the roses. This is a cliff rose. They only grow in limestone. There's a limestone layer here going up to the top of the mesa, which is volcanic. And the cliff rose grows where the limestone is. And you could smell these plants. They're aromatic, and the bees are buzzing all over them when they bloom. Next. Brian Bates, my archaeastronomy mentor. Jerry Granny, Rebecca Durenberger, my PowerPoint facilitators, etc. Lee K1 Wysioma, Scott Thibany, Bob Talarvik, Norman Honani, Tony Marinello, nighttime photographer, and Naval Observatory Data Services. Without all this help, this wouldn't have happened. That's it.